Alright, welcome to Lab 1 of Physics 2212. My name is Raquelme. Let's get into it. So the introduction of the lab, the idea is to understand what a charge is, to design experiments using common everyday objects, to learn how to make estimates and assumptions, and to understand the amount of excess charge on everyday objects. So the purpose is to prepare charged pieces of Scotch tape, and then observe how they interact with other pieces of charged tape, and conduct an experiment to determine how many excess energy is on one piece of charged tape. And so before we get into that, it's just important to understand that objects can gain excess negative energy or lose it if they are rubbed in different manners. Due to the way electrons work, the absolute value of the net charge on a tape is between 1.6 times 10 to the negative 19 coulombs and 1 times 10 to the 5th coulombs. And so since this is a wide range, we're going to conduct an experiment to see what is exactly the net charge of the tape. So the material we'll be using is a roll of clear tape, a ruler, a flat surface, and 2 thick books, or just objects that can hold the tape. To the preview, the charge on each tape was 1.65 times 10 to the negative 8 coulombs, and the number of electrons lost by each tape was 1.03 times 10 to the 11th electrons. And so fundamental concepts that we'll be using for the lab are Newton's second law, which is up at the top right. It's an object acceleration is directly related to the net force, and it's inversely related to its mass. Force equals mass times acceleration. And then Coulomb's law, it just describes the amount of force between two electrically charged objects at rest. That one's in the middle. And then gravitational force equation is just relates to the force between any two given objects with mass. That's the bottom right. And so initial conditions. The tape mass, the tape length was 0.4 meters, and the tape width was 0.02 meters. And given that the tape's density is 1 gram per meter, we can conclude that the mass of the tape, of this segment of tape, was 4 times 10 to the negative 4th kilograms. And then the tape area was 0.008 meters squared. And then atom area is 1 times 10 to the negative 10 squared, which was 1 times 10 to the negative 20th power 1 meter squared. And number of atoms was 8 times 10 to the 17th. And so initial expectations and observations. My initial expectation was that they would probably repel since they would have the same charge. And yes, that was true. They repelled but attracted neutral objects like tables. And since when we tried to charge tape with a pen, which was negatively charged, so because they attracted, we were able to conclude that the tape would be positively charged. And so physical experiment, the system was tape B right there as red, and then the surroundings was everything including tape A right there listed as blue. And the distance when it began to move, tape B, when it began to move, was 0.025 meters. And so these were the calculations. The gravitational force on tape B using the gravitational equation, we got 3.924 times 10 to the negative 3rd newtons. And because the electrical force on tape B and the gravitational force on tape B are proportional to each other in terms of magnitude, we can conclude that the electrical force is the same, that it's just pointing in the opposite direction. And then the electrical charge, using Coulomb's law and using the electrical force that we got, we concluded that it was 1.65 times 10 to the negative 8 coulombs. And then the number of electrons lost, we concluded that it was 1.03 times 10 to the 11th electrons. And so this gives us a ratio of 7.76 times 10 to the 6 atoms per electron. And this was, we concluded, based on the number of atoms that were in the tape. So here's a computational model. It just pretty much just reiterated what we had calculated already. You can see the top tape and the bottom tape there with the two forces that acted onto tape B. And so the assumptions that we had to make were that air resistance and friction were negligible. The tape segments were assumed to be point charges, and the segment tapes had the same amount of evenly distributed charges. errors. The loss of charge could result from the handling of the tape and or the environment, and then there could be an unequal distribution of charges on the segments of tape. Lastly, the what if. What if electrons had positive charge and protons had negative charge? What would change about the observations made? Well, nothing really would change. Everything would be the same, except that we'll be solving for how many protons were lost instead. And then the why. It's important to handle the charged tapes as little as possible. This is important because it was to prevent the neutralization of the charged tape, since when they came into contact with other objects, it would try to attract those lost electrons. And that's it. Thank you.